So, hello, my name's Yariv, and I lead product management for API security within Akamai. And I wanted to talk a little bit about things that we've been seeing at our customers and how we really feel that a lot of those issues could have and should have been solved at the design stage of things. So I'll touch on the problem, then we'll look at two real examples, heavily reducted, just so that we have some point of reference. Then we'll be basically looking at something that should be clear to everybody in the room, which is why we should be focusing on design. Talk about 3 common design pitfalls that we've been seeing, and talk about how to address those. So, the problem. Basically, APIs power the business, and everybody here is under a lot of pressure to deliver, right? Quickly. But they're also the #1 attack surface. And this is only being exacerbated now that we are having all this agentic AI revolution. So some numbers to support that. And some of these are a bit stale. For instance, the first one, I think it's actually from the Akamai State of the Internet report back in 2023 and not 24 as I've written here. So I think it's considerably higher now. But it's more than 1/3 of the internet traffic is actually API traffic, and it's rapidly growing. We've actually been seeing a lot of AI bot traffic over the past year, and it's been growing exponentially. And the bulk of it, you can see in the graphs, I remember, is actually when the models are learning. But then you already see the assistants and a bit of autonomous agents coming into it. Prevalence of the issue: 78% of companies experienced an API security incident in the last 12 months. From those that we polled, it happens a lot more frequently than you see it in the press. And it's usually when they engage us and we're like, oh, this is nice, but maybe we should have done this a bit earlier. Then the impact, right? When there is an API breach, actually, it's an order of magnitude more impactful than any other type of breach in terms of the records that are exposed out there. And we know that the cost for the organization of handling a breach is almost $4.5 million. So when you guys need to go and manage up and manage out, towards your peer, you definitely need to leverage those numbers in order to drive change throughout your organizations, because I'm sure you're unhappy with a lot of things and you think that they should be done differently. So, 2 real examples. BOLA, right? We all heard about BOLA, broken object level authorization. Basically, getting authorization is very hard. We were at the unconference yesterday. We talked about that quite a lot, I have to say. And it is, therefore, the #1 thing out there for the OWASP API top 10 vulnerabilities. Actually, if you zoom out, I think 4 of the OWASP top 10 are around authorization issues, right? And this can lead, and I won't tell you which one of those is it in this case, but it could lead to unauthorized access of sensitive health information, opening, unlocking someone else's car door, etc., right? So the ramifications here are horrible, and it's super prevalent. And this is actually one of the alerts from one of the customers in our product. We've been monitoring their production APIs, and we've actually seen those 2 red lines over there, and you can see the resources being accessed by 2 different users that actually have access to the same protected resource that they should not have access to. And this is happening to huge Fortune 50, let's say to remain vague, enterprises out there that are doing everything right, but still you feel some little thing, and that's a problem. Example #2, which is again super trivial. Input sanity checks, right? I mean, come on. We never trust anything that the client gives us. So it really, it's a question of how you classify that with the new OWASP API top 10 from 2023. It could be #6, could be #8, I guess. But obviously everybody's testing inputs, and still someone has managed to have minus $250 for their tax and check out something and actually get quite a big discount. Yeah, and this is happening, right? This is actually happening out there, right? So very clearly, we have a problem, and we don't want to be finding it in production. So what should we do? We should focus on design. And why is that? Because when we're securing the software development lifecycle, which is really sort of this, and of course it's circular, and you can write it as an infinity loop, you know, you start with design. And design is really, you know, are we calling for authentication, authorization, and rate limits, or are we forgetting those things? We'll talk about that. When we're coding, are we checking, are we testing our code? Are we running code scan with static analysis tools, with software composition analysis tools to ensure that we're not introducing vulnerabilities or that from us, from our code, or from third-party code? And are we running actual dynamic tests to see the actual code as it behaves in runtime? Then, of course, do we have a gate to ensure that we've done at least some of this before we deploy the code to production? And then are we really monitoring what's going on in production to see how the clients are interacting, right? And of course, we all know Baum's curve, which says that if it's 1 unit of effort or cost to fix something at the design or requirements phase, it becomes exponentially more expensive as we go up, right? So 5 to 10 when you're fixing it during the coding phase, 10 to 25 times when you're fixing it during testing. And if it's in production, 50 to 100 times. And of course, it's been proven yet sort of qualified over the years because this is ancient knowledge from the 80s. So I think it's not times 100 right now because of all of the CI/CD automation we're all doing. It's times 15. But if you think about security ramifications, then it's definitely times 100. Because there's incident response, there's, you know, the fines that you're going to get from, you know, breaking compliance, et cetera, et cetera. So this is horrible. And naturally, we want to fix things where there's the biggest bang for the buck. Now, if we were to implement all of those sort of processes and security controls I alluded, that also, of course, has cost, right? And that cost is not only in the tooling, but actually embedding them into the work processes, maintaining them so that they're alive, and ensuring that the developers don't find it hard and annoying on, you know, when they're going about their daily chores. So that's important. So we should be focusing on design. And we can actually trace most of the breaches back to design decisions that were taken or actually not taken. And this is when I want to actually switch gears and look at 3 design pitfalls that we've seen. And often we see them either through our testing product or when we monitor pre-production and production. Number 1, fumbling. I would call it authentication and authorization. We know that. And of course, so actually I think there's a statistic from Gartner that 80% of all of the API-related incidents trace back to data access problems, right? So it's authentication and authorization. The number of unauthenticated APIs out there accessible to the internet that we've seen is staggering. And this is just authentication, just tell me who you are, right? Then of course, you told me who you are. Are you allowed to see this information? Okay, not necessarily, right? So that, of course, happens again. If we were to fix this, right, we would have taken care of that broken object level authorization vulnerability that we've seen previously, right? So it's that. Now, why is it happening? It's happening, well, first of all, because we're not always thinking about it. We're thinking, hey, we're writing this API now. It's an internal API. Nobody's using it. It's just for the team and the other team over there. And then they're using it, but they're actually maybe 2 months from now exposing it via their API to the outside, and everything is infected with those assumptions. So naturally, we should be never trusting anything from the client, which makes sense. And in order to make the developer experience not suck, we probably want to introduce some sort of an authorization framework that everybody can use and that's easy to use. So that would be the default, right? And in that example that I've given, they actually did do that, and the developer still managed not to use the framework and messed up. So even if you do all of these things, mistakes can happen. So that's number one. Number two, being overly permissive. And it sort of relates to the previous one that we've talked about. But actually, let's look at it at the single API level, right? We have a resource. We're thinking, yay, we can serialize it to the database. We can deserialize it from the database. Easy. Why not serialize all 25 fields or attributes of that resource in and out and just, get/user and give it away? Because it might contain the user email address and their shoe size and health information and I don't know, various fields that maybe we don't need depending on the actual use case. One of the things that I think stood up to me from the discussions we had in the unconference yesterday was that quite often what the developers are missing is clear requirements, like product management work, sorry, I'm product manager, and defining what is the use case, what needs to happen, what needs to be done. And people on the stage alluded to that also earlier in earlier talks about how the requirements are sometimes vague, and then you can't write an API properly, right? So we should be thinking about list privilege and actually not giving all the information, but only the required information. So it's not an opt-out thing, it's an opt-in, right? So nothing by default besides the fields that you need. And this fixes a vulnerability that's super common. It was called, I think, mass assignment, right? When you sort of just give the entire object and override the isAdmin with true, because, yeah, everything gets serialized. And now I think they call it BOPLA, which is the broken object property level authorization. Again, authorization issues, right? So being overly permissive happens a lot. Last, but definitely not least, and I think this is sort of the most complicated ones, or that leads to the most complicated abuse cases. And that would be trusting the client. And not necessarily, sometimes it's the user, sometimes it's the client, it really depends. But basically, we cannot trust that the happy path would be the normal path of operations, right? What happens when someone retries the same transaction twice? Are we charging them twice? Or do we have idempotency keys, right? What happens about input validation? Have we defined that properly? Yes, it's a number. Yes, but have we defined that it's between 0 and something, right? And not minus 250, which goes back to the previous problem. How are we doing that? Do we have a framework in place which makes it trivial for the developer to use for all the developers across all the APIs, right? And then, are we managing the state on the server side, or are we relying on the client to call A, and then B, and then C? And if the client calls A and C, we don't notice. And B was payment, right? So those could be problems if we rely on the client being nice. We shouldn't be relying on any business logic over there. So what are the design principles that we should take from all of these things? Basically, we need clear contracts that would prevent misuse, right? And if we want to be secure, we just need to write our specifications. And we need to make sure that the developer experience around all of this is super easy, or you get zero adoption. Nobody's going to use it. It's just going to be some process that nobody follows and finds a way to work around, right? Which means that we have to be, if we are in charge of security in the organization, we have to be really, really quick to react and provide feedback. So if it's the AppSec team or the security architect, or maybe the the product architect has been delegated to handle some security issues, give feedback quickly, work with the developers on those things, and make sure that developers don't have to think about it. Just it's secure by default, embed the frameworks in there so that it's all secure by default. So 3 takeaways. Number 1, start with specification. And that specification needs to include the important stuff. What's the important stuff? Everything that we talked about in the last presentations, about, you know, design stuff. But really from a security perspective, 3 things. The authentication authorization requirements. And if you're using OpenAPI, you could use the security schemes, right? And basically specify very, very clearly for each and every API which authentication is needed, which scopes it accepts and does what with. And then you go to do validation rules, which you can leverage the JSON schema fields in OpenAPI specifications if you're using that. If they're not flexible enough, you can go into the extensions, and definitely don't forget rate limits, right? And those should be enforced globally for all of your APIs. Usually what we find people do is they have the normal rate limit per user, and then they have exceptions for certain APIs, etc. If you don't do that, you will suffer from denial of service, basically. You will be denial of servicing your own applications, especially now with you know, agentic AI. So you're going to have new users that are very unclear about their usage patterns, and they're going to be exhausting your APIs, exhausting the resources for some of those APIs, etc. So do specify rate limits, spike arrests, etc. Then it's all a procedural problem. Right? This is a management problem, a leadership problem. We need to be managing up, down, left, right, because we have to ensure that the process is in place, right? So there should be a design with everything that we just talked about, but then it needs to be reviewed, right? And this needs to happen before the code is written. It must include all of these things and some of the things that are listed here as well. It would really be nice if it would include some threat model, which I find very, very few companies actually do. But even if it just would include a list of the malicious user stories, that'd be nice, right? So if I were a malicious user and I would be using this API, what would I be able to do? You need to really think about it differently and think, I'm bad. I want to do something bad with this API. And make sure that you have abuse prevention strategy against it. Could be the rate limits, could be something else, but you need to figure this out. Right? And then this needs to all happen by default. And then, again, from a management perspective, we need to measure. So we have leading indicators, we have lagging indicators, but we need to measure that this is all actually happening and working across the organization. How many APIs have a design review? What's the mean time to AppSec or that security architect response, right? And then we have the lagging indicators. Are we seeing, you know, the incidents actually decline? Are we seeing the findings from our testing tools declining? And then we know that we're on the right track and we're not hindering development, we're actually accelerating it and generating more secure results. So that's the summary. It's a process and systems problem. It's sad. It will require everybody to be involved with politics and managing and stuff like that. But that's the case. And the most efficient way to secure APIs is really through secure design. And for actual adoption, we have to ensure that the developer experience is superb, or they will find a way around it. So that's it. Thank you very much.